This is a basic stoichiometry problem. We have the amount of one reactant, 10 grams of nitrogen, and we're wanting to see how much of another reactant that we need to react with that. Conversion factor problem. We start with our given. And then whenever we're doing stoichiometry with a chemical reaction and the amounts, we always want to convert to moles first. In general, in chemistry, converting to moles is a very common first step. And I'm given the molar mass here. I got those by adding up the atomic weights from the periodic table, but sometimes I give those to save time. Okay, and then I know I want moles of nitrogen down here. Once you get to moles of something, then you can switch compounds. Then we can start going to the compound or the element we're interested in. And to do this step, we use the coefficients. So the coefficients, this one is 1 and this one is 3. So with the nitrogen I had a 1 and the hydrogen I had a 3. Okay. So right now, if I solve this, the grams would cancel, the moles of nitrogen would cancel. My answer would come out in moles of hydrogen, and it asked for grams of hydrogen, so I've got one more step. And this is a molar mass step. There are 2.02. The number goes with the grams per 1 mole. And the answer I got was 2.16 grams of hydrogen. Okay, a few things I want to point out about this that are important. First of all, notice that when I wrote this, I said moles of nitrogen, grams of hydrogen. I told the compound or the element in all of these steps. I kept track of that. And that's because this problem involves two different substances, and I need to make sure that I'm not canceling grams of nitrogen and grams of hydrogen or whatever. So in stoichiometry, two different substances, be sure to write the substance identity on each step so you don't mess up on that. To point out to the basic steps here, this was a molar mass step. This one was molar mass of nitrogen. This is a coefficient step. You need to make sure your balanced chemical equation is, that it's actually balanced at that step, that it's not just reactants and products. This, again, is a molar mass step. So this is a very common pattern in stoichiometry.